ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಾವು ಲೈನಕ್ಸ್ ಎನ್ವೈರ್ಮೆಂಟ್ ಬಗ್ಗೆ ಹಿಂದಿನ ಕ್ಲಾಸ್ನಲ್ಲಿ ಕಲಿಯುತ್ತಿದ್ದೇವೆ. ಇಂದು ನಾವು ಸೆಷನ್ 13 ಇದನ್ನು ಕಲಿಯಲಿದ್ದೇವೆ. In this session, we are going to discuss about system call. In particular, the system calls that are used in the file system will be discussed here. Namely, I am going to give you the syntaxes for open, read and write system call. The learning objective of this module is to study the system calls for the file system. In order to understand the concept which are discussed in this section, you need to have the basic knowledge of Unix file system. The system calls for the file system are categorized into different sections based on how they are being used, what type of activity they perform, and what are the return value. So you can notice over here there is a brief sections about different classifications of the system calls which are used for the files. Now you must understand that all these system calls which are discussed over here in turn make use of some of the algorithms or some of the other system calls which are there at the base level, and they are the lower file level algorithms which are used by most of the system calls which are listed in this section. Now let's look at the classification of the system calls which are used for handling the file. The first classification is based on the return file descriptor. Now whenever we call this system calls, they are going to return us a file descriptor. There is a other category of system calls which use one of the famous algorithm, that is the name I algorithm. Now this name I algorithm is used to map the file name with the inode or the inode with the file name. I have discussed about this in the previous sections. If you want to know more about them, please refer the previous videos. We have other categories of the system calls, and they are used, in particular they make use of the assign of and free inodes using the ialloc and ifree algorithm. Now let's look at the different categories that are being used. Now we will notice that there are many system calls like open, create, dub, pipe and close. Whenever we call this system calls or whenever we make use of this system call, they return a file descriptor back to us which we can use it for further processing. There are other algorithms like open. Even though it returns the file descriptor, it in turn makes use of the name algorithm. So we know very well when we studied about the C programming, we have made use of the open or create to create a file. Now when we want to create a file, we usually specify the name of the file. Now this name, we know very well, has to be mapped to a inode number, and this mapping is done by the name algorithm. There are many other system calls that makes use of the name algorithm. There is a other set of system calls that are used to assign the inodes, such as the create, make node, link and unlink. Let's look at other types of system calls. There is another classification of the system calls that either set or change the attribute of a file. There are also the system calls that do the input output to and from a process using the algorithm such as the alloc and free. These make use of the buffer for allocating and maybe deallocating. Let's look at the different system calls that are being used. So the system calls that are used to change the attribute, like the owner of the file is chon. We can also use chmod, that is command, to change the attribute of the file. So when we try to change the attribute of the file, these type of system calls are classified as the system calls that makes changes to the file attribute. There are also the input output file operations, which are whenever used, they have to either allocate or deallocate the content from the buffer. Like when we try to read, the data is read to the buffer, and when we write, the data is written from the buffer to a particular location. There is also a category of system calls that change the structure of the file system. Also, there are system calls that allows a process to change the view of the file system in the file system hierarchical trees. These system calls are mount and unmount. So when you mount a file system, the structure of the file system expands. When you unmount, the size or the structure of the file system reduces. Again, by changing the directory or by changing the ownership towards a directory, we can change how much content we can see or what is shown for a particular user. Now let's look at one of the system call, and this system call is the open system call. Now this open system call is generally the first system call that is used before processing the file. So this is the first step in processing a file. The syntax for this open system call is, we use the word open followed by a parenthesis and then path name where the file exists, the flags that I use for the opening, and the mode in which we want to open the file. The path name refers to the path in which the file exists, that is the path of the file, that includes even the file name. The flag that is used to indicate whether we want to read from the file or whether we want to write to a file. The modes include the permissions that are used for opening the file. Whenever we call the open, we are returned with a file descriptor. This is an integer number that indicates the file descriptor that is being used in the other processing. Once we open the file, we have the other system call that can be used to read the content from the opened file. So the syntax for the opening or reading the system call is, we use the word read followed by the parenthesis, and we use the file descriptor that is obtained in the opening of the file. So the file descriptor that we obtain when we open a file, that has to be used. So we use the file descriptor, and the place where the read content has to be stored, that is the buffer, and how much we want to read, that is the count of bytes that we want to read. Now we may specify many count, so we may say that 100 bytes has to be read, but if the file ends before that, the read will say what was the real number of bytes that are being read. Even though we may say that I want to read 10 bytes, in reality the read operation may read only 9 bytes. So this read operation will always return what is the actual number of bytes that are written, and the count indicates what is the expected number of bytes that need to be read. So the FD is the file descriptor, buffer is the address of the data structure where the content will be read, count is the number of bytes that the user wants to read, and the number is the number of bytes that are actually read. Then we have the other system call, that is the write system call. So the write system call is used to write the content from the buffer into the file descriptor. So EFT is the file descriptor that is obtained by using the open system call. Buffer is the address of the data structure from where the content will be read and transferred to the file that we are, in other words, where the place from where we want to read and transfer those content to the file. Count is the number of bytes that the user want to read, and again the write will also return what is the actual number of bytes that are written. Now, when we try to write the content into the disk, okay, the file may not contain the block. We know very well. Whenever we want to write something, we have to use the inode, and in the inode, there is a pointer that points to the actual place where the content has to be written, the block where the content has to be written. Suppose if the when we try to write, if the block does not exist for that particular offset, then the kernel will allocate a new block using the alloc algorithm, and then it will set the proper block number in the inode table, and then it writes the content to the disk. Again, it may so happen that we know very well that there are direct and indirect. Suppose if it is the indirect block, then we know that indirect block in turn contains the other blocks. So if it is an indirect block, then the kernel may have to allocate several blocks before writing the content into the disk. Okay. While writing the content to the disk, the inode is locked because if the others read the content when the things are being written to, then there is a chance that there could be a confusion while writing. That's all in this session. Thank you for your interest. We will meet again in the next class. Thank you.